So we've got a boat. We've got a boat that's traveling. Oh, hey, look, they do have a picture here. I've been drawing it right here. We have a vector velocity, 8 kilometers per hour. So 8 kilometers per hour. I didn't even realize that this was set up for this problem. Yeah, that makes sense. And then there's water that pushes it south at 5 kilometers per hour. So we're looking for the resultant velocity of the motorboat. This is super easy, right? Because we know a squared plus b squared. We're going to take the square root of it. And so this is pretty much just review, getting us ready. If we're in 2D motion overhead view, a squared plus b squared equals c squared. So take the square root of both sides, and I've got 8 squared plus 5 squared. I take the square root of both sides. 64 plus 25, that's 89. Root 89 equals C. I think. 81 is 9, so this must be like 9 point something. 9.4? Okay. 9.4 kilometers per hour. That's this diagonal, 9.4 kilometers per hour. And we're looking for the resultant velocity. We need a direction as well. So why don't we report back this direction as it goes east and south. We can figure out how much south of the east line it goes by using inverse. So inverse tangent will give us inverse tangent. What do we need to plug in?
5 divided by 8.
Right. So normally tangent of the angle will be opposite over adjacent, but we have the opposite 5 and the adjacent 8. And so doing the inverse tangent will give us the angle. And so we have it at 32 degrees. Right, we type that in the calculator. You got 32 point what? Ah, cool. I'm good with 32 then. 32 degrees, what of what? South of the east line. So here's my angle right there. And that's my answer as a full-on velocity. It's a vector. It has a magnitude, unit, direction. How much time in minutes does it take for the motorboat to travel shore to shore if this width is 1,500 meters, 1.5 kilometers? So am I going to use the 9.4 that we just solved for, or am I going to use the 8? Yeah. We only care about how we're moving side to side. So why don't I use the side to side speed for the 1.5? Wait, so then all I need is the distance divided by velocity is equal to time. So that's 1.5 divided by 8. And then I'm going to do some dimensional analysis because this is in kilometers per hour. So how am I going to get it into minutes? Multiply by
300.
Nope, too far. Just 60. 1 hour is 60 minutes. I don't need to go to seconds. It wants it in minutes. 1.5 divided by 8. What do you get with 1.5 divided by 8? I want that first. 0.1875 hours. And I'm just going to put that in parentheses because my real answer is 11.25 minutes. Okay. And that's just the fact that I did 1.5 divided by 8 to get that hours first. Why? Because it's probably helpful for us now. Now, in my picture... Oh, I've moved my page far down. I want to know this distance right here. How far offstream it is. That's what part C asks us for. How far downstream we've been pushed. So how far downstream the boat will be? Wait, we know the time that we're going to take to sail across, and that's how long that we're going to be pushed downstream. That's how long we're in the river altogether, is 11.25 minutes. Which means we know, yeah, x equals v times t. And we know our speed is 5. And our time is 0.1875. I'm going to use my hours. Now you see why I kept the hours there. Hours, because this is kilometers per hour. 5 kilometers per hour times my 0.1875. I still haven't been using my calculator. Y'all been on it. What is it? 9375 kilometers. So 937.5 meters. That's how far off target we are, right? If we were just trying to go from one side to the other side, we end up getting pushed by the water down. So instead of getting pushed down, the next one says, hey, what if we don't want to get pushed south? What if we want to end up just straight east? How are you going to point your boat?
34 degrees.
So if I'm trying to go across the water this way, this is what I want, to go straight east. That's my want line. I'm going to take my heading, and I'm going to point my boat this way a little bit with some angle, because then the water is going to push me back down. And what ends up happening is that the boat looks like it's facing, this is an overhead version of the boat, looks like it's facing down that diagonal line, but it will travel completely horizontally. This is where I started showing y'all airplanes that were being blown on to the runway, right? And so they look like they're facing one way, but as they land, they have to straighten out just at the very end, okay? So this is the path I want to travel. And so as our engines push this way, the water blows us onto course and the current pushes us onto course, and we go completely horizontally. So what do we know our engines are doing? What strength are they? How fast are they pushing us?
8 kilometers per hour.
8. And then the water is moving at 5. So really, anytime we want to hit our destination exactly, instead of finding the diagonal, our engines create the diagonal strength, and we get blown onto course as one of the legs, and we really need the straight line vector of navigating into the wind a little, which means we found a leg instead of the hypotenuse. So how do I do this? Wait. We need the angle first. How do I find the angle?
Tan. No, not tan.
Trig. I'm going to use sine inverse. Why did I use sine inverse? Opposite and the hypotenuse, right? Will give me my angle. So where did that come from? If the sine of the angle gives me my opposite over hypotenuse, but I have the opposite and I have the hypotenuse, I can find the angle. So, inverse sine of 5 over 8 needs to be less than 1. I think it throws an error if it's more than 1, right? It's been a while. Didn't even touch the calculator today. So y'all got 38? 38.68? Is that what you said? Degrees. And I have to point my boat north of east. That's the way I point my boat. That's the answer. How long in minutes would the trip take in part D? Well, now I need the leg length, right? So 8 squared plus 5 squared equals... No. We need to find a leg. And so it's if a squared plus b squared equals c squared, but we have two of them, why don't I just subtract? Or take the square root of both sides, get rid of that. So, oh, y'all can't see anything that I just did. Wow. If a squared plus b squared equals c squared, but we have the diagonal, then we can just subtract. 8 squared minus 5 squared, and then take the square root of it. 64 minus 5, 25. 64 minus 39. Square root of 39, 36 is 6, remainder 3, 6.24. I'm guessing y'all used a calculator for that decimal that fast. It would have taken me a little while longer. 6.24 watts. Okay. That's not our answer. I want to know how long in minutes does it take. How far am I trying to go?
15 to 300 meters.
So 1.5 kilometers divided by 6.24 kilometers every 1 hour. And of course I want it in minutes, so multiply by 60 again. My units cancel out. Kilometers top and bottom. This is hours at the top with an hours at the bottom. I know it's like underneath, but that means it's the reciprocal, right? Two. I got 14.4. minutes. Check it. Your calculators agree? You taking my word for it? I mean, I have last class periods notes. It's in the trash somewhere. Don't make me dig out of the trash. I ate lunch since then.